For this question, we want to decide whether each is an observational study or a controlled experiment and explain why. Okay, part A. To study the effect of smoking on lung capacity in women, you find 100 women age 30, of which 50 have been smoking a pack a day for 10 years, while the other 50 have been smoke-free for 10 years. You measure the lung capacity of each woman. So in this case, we would have an observational study only, because there was no assignment into groups. The women chose on their own whether they were going to smoke or not, right? So all you are doing then is observing the features about these women, their lung capacity, but you did not control any part of what has happened. B, a group of children is randomly divided into two groups. One group drinks a colorful, sugary drink, and the other group drinks water. The behavior of the children is recorded for several hours afterward. Okay, so because there was some random division into two groups, and then one group gets the treatment of the sugary drink and the other group does not, the controlled group drinks water, this is definitely a controlled experiment. Okay, for those reasons I stated. For the randomly division of groups, you've got your treatment and your control. Okay, then it says, let's assume that the researcher knows which children are in which group. How might that affect the conclusions drawn? So if the researcher knows exactly which kids have drank the sugar drink and which kids have drank water, what I think might happen is they may see behaviors in the sugar group that they just ignore in the other group. It's not always, this isn't guaranteed to happen, but it could happen. So they may see more behaviors in the sugar group just because they expect to, basically. So they may see these children bouncing off the walls and being crazy, and they're like, well, yep, they drank the sugar drink, and so I'm noticing this. Whereas maybe one or two or more of the children in the water group are also kind of running around and acting crazy. And perhaps the bias that enters into our minds subconsciously causes the observer to just think, oh, that kid's just being a kid. Like all kids run around and all kids jump off of things. And all, so they may just sort of have their own biases enter the situation there. I could also see how if the kids know what's going on, I mean, it's probably pretty hard to blind them here. They're going to know whether they're drinking water or not. But definitely if the kids know what's going on and they know they're in a study, do you think kids might act up on purpose? Like if I got this sugar drink and I know what they're looking for, maybe I'm going to act a little bit extra crazy today. So that's also things that can happen when the blinding doesn't happen on the subject side. I'm not sure that you could blind this that way, but it's just something to be aware of. In the next example, we've got a group of overweight people are asked to participate in a weight loss program. Participants are allowed to choose whether they want to go on a vegetarian diet or follow a traditional low-calorie diet that does include some meat. So both diets. Half the people choose the vegetarian diet, half choose the control group and continue to eat meat. Suppose that there is greater loss in the weight loss in the vegetarian group. Okay, so because they're choosing, I see this word choose all over the place. The subjects are choosing for themselves what they're going to do. So this is definitely an observational study. That means there's most likely confounding variables. So we want to suggest a plausible confounding variable that would prevent us from concluding that the weight loss was due to the lack of the meat. So people willing to change their diet drastically may also be changing and that's kind of where your mind wants to go. So I would think maybe they are changing their exercise. Maybe they're changing their vitamins. Maybe they're changing their sleep habits, etc. So if you're willing to kind of do the more extreme dieting, you're probably willing to do other things as well. Now, any one of those things could be affecting the weight loss. So a better way to do this experiment that would remove the influence of confounding variables would be to randomly assign the people to each group. Again, you're not really going to be able to blind them in this case because you're going to know if you're eating meat or not. So some of those other things may not really apply here to make this better. Definitely I would do, it doesn't mention anything about your sample size, but I would make sure that you have a large sample as well. Because if you only do this with a handful of people, then your results are not going to be all that great. So make sure you have a large sample and definitely randomly assign those people into their groups so that you can try to control those confounding variables. So a little bit more on variables. We've got what we call qualitative variables. Another word for that is categorical. So those describe a quality or a class of the objects of interest. So these could be like hair color, eye color, your favorite food. These are categories, qualitative data. And then we have what's called quantitative. I accidentally spelled this incorrectly. Quantitative data, which is numerical. So these are quantities or measurements. So this could be height, weight, temperature, the number of members in your family, etc. Once you have quantitative data, you could have discrete or continuous. So discrete variables are numerical variables that you can list or count. So an example would be the number of students in our class, right? We can list or count that 1, 2, 3, 4, 5. The difference between that and a continuous variable is that the continuous variables cannot be listed or counted because they occur over a range. So basically what that means is that all of the little decimals and fractions can occur. For example, the length of time of your next phone call. So as precise of a timing device as you have, you could time it down to the second or the millisecond or the nanosecond. So you can time these down to very tiny little decimals or fractions, and that's what makes it continuous. I can't write out all times because there's always like a smaller little fraction or decimal that could be found. So we want to determine in number 3 down here which of the variables in this data set are categorical and which are numerical. And if it's numerical, decide whether it's discrete or continuous. Okay, so first I'm just going to go across the top and let's label them either C for categorical or N for numerical. So gender would be categorical. Height is definitely numerical. Weight is also a number. Your birth month is a category. Course grade given as letter grades would be a category. Now, if those were given as percentages, then they would be numbers, but since they're given as letter grades, they're categories. And your family size would also be numerical. Okay, so only if a variable is numerical should we talk about it being discrete or continuous. Okay, so height. Height measurements, again, I could measure that as precise as I wanted to. I could measure that to inches or half inches or quarter inches, an eighth of an inch, and just on down into these tiny little fractions and decimals of inches. So this is considered continuous. Weight is the same way. These are all reported to the single pound, but they could definitely also be, decimals or fractions of pounds. So that would be continuous as well. Now notice how those measurements are different than your family size. My family size can only be whole numbers. There would be no such thing as having, 4.5 people in my family. So this cannot be measured down to these very small little fraction and decimal precision. They're only counted in certain increments. So this is what we would call discrete.